Oh, welcome back, you guys. We'll take a look today at u substitution with definite integrals this time. Definite integrals. Last time we did it with indefinite integrals. So notice this time we actually have these lower and upper limits. And that's primarily the difference here. So with our u substitution, if you remember from last time, we're usually letting it be like a radicand inside the radical, or a denominator, or maybe it's the radicand of the denominator, and so on. And that will usually do it for us. So let's go ahead and see if this will work out for us. Let's let u be 9 plus x squared, so that du dx is derivative of 9 is 0, derivative of x squared is 2x. Take the dx to the other side. And if you notice, we have an x dx. We don't have a 2x dx. So let's throw a 2 in. There's our 2x, which means we got to offset it. All right. So we have 1/2. We have the integral of 2x dx from 0 to 4. Again, here's our du. And we've got the square root of u right there. Now this is from x being 0 to x being 4. And let's go ahead and run the integral now. So we got 1/2, then we'll run the integral u to the 3/2 all over 3/2. But this is from x being 0 to x being 4 this time. So don't put the plus c on there, because we've got the lower and upper limits here. So we got 1/2 times 2/3 u to the 3/2 from x being 0, x being 4. So we got 1/3 u, which if you remember our u is that x squared, 9 plus x squared. So notice I go back to the x's from 0 to 4, because this is x being 0 to x being 4. Now let's throw the 4 in. Now we'll throw the 0 in. We got 9 plus 16. We got 25. 3/2. 9 plus 0. 3/2. So we got 25. Let me write it this way. That's to the square root of 25 to the 3rd. So 5 to the 3rd minus 1/3. Square root of 9 is 3 to the 3rd. So we got 5 times 5 times 5. What's that? 125 minus 27 over 3. And so we got 98 over 3. And that's our integral for that one. If we look at this next one, hopefully you're thinking, well, I'm probably going to let that u be the denominator. Because my du, derivative of 3 is 0, derivative of 2 cosine of 2 stays there, derivative of cosine is negative sine, and d theta. So du is negative 2 sine theta d theta. Du is negative 2 sine theta d theta. So I need a negative 2, and then I need to offset it with a negative 1/2 out front. Right? So I have negative 1/2. Integral, notice the negative 2 sine theta from 0 up to pi halves. Again, here's my du. And so I've got 1 over u squared. And our u is that 3 plus 2 cosine. This is theta being 0 to theta being pi halves. So we got integral of u to the negative 2 du Now we go ahead and let's run it over here. I got negative 1/2 u to the negative 1, negative 2 plus 1 all over that negative 1. So negative over a negative is a positive. So I got 1 over 2 u to the 1. So 1 over 2u from theta being 0 to theta being pi half. So make sure you change the u back to what the u was in terms of theta, which was 3 plus 2 cosine theta. And so we've got throw the pi halves in, minus. Now let's throw in the 0. And we've got cosine pi halves is 0. Cosine of 0 is 1. So I got 1/6 minus 1/10. So I got 5/30 minus 3/30 or 2/30 or 1/15. Ends up being 1/15. Now let's go ahead on this next one. We'll go ahead and let u be that radicand again. So u is the tangent of theta. So du would be derivative tangent secant squared. And notice there's our secant squared. So that'll be our du. So we'll have the integral of the square root of the tangent. That's u. And then we've got secant squared d theta. There's our du. From theta being pi force to theta being pi. So we got pi force to pi, u to the 1/2 du. We'll go ahead and run that. So u to the 1/2 plus 1 is u to the 3/2 all over 3/2. So that's times 2/3. From theta being pi force to theta being pi. So we have 2/3 the tangent of theta to the 3/2 from pi force up to pi. And now we'll go ahead and we'll throw in the pi. So we got 2/3 tangent of pi to the 3/2 minus 2/3 tangent. Now we'll throw the pi force in to the 3/2. Well, tangent of pi is sine of pi over cosine of pi. Sine of pi is 0. Tangent pi force, that's sine of pi force over cosine pi force. That's root 2 over 2 all over root 2 over 2. So I just got a 1 right there. So that's gone, and I'm just left with 1 to the 3/2 is 1. So I get negative 2/3 times 1, which is just a negative 2/3 on that. Now this next one, hopefully you're looking at that thinking, well, if I let u be 4 minus x squared, I got a negative 2x. I don't have any x here, so hopefully you're going to your reference sheet at this point and you're noting that you have this formula, 1 over the square root of a squared minus u squared, that it'll fit. And this is the arc sine of u over a plus a constant. Okay? So that's what we're going to use here. To help us to solve this. This is from 0 to 1, 1 over, let's write it this way, that's a 2 being squared, that's our a, so our a is 2, minus our x is then being squared dx. And so, you know, you could let u be x, but obviously du would just be dx, right? You don't need to because it's just x. Right? U there. So a is 2, u is x, and you're good to go ahead and write that this becomes the arc sine of u, which is just the x, over a, which is the 2, from 0 to 1. So then you take the arc sine, put the 1 in, and then you take the arc sine of 0. So you got the arc sine of a half. So you got pi sixths on that, minus the arc sine of 0, which is just 0. So you got pi 6 minus 0, just pi sixths, right? Remember, if the arc sine of a half equals theta, then the sine of theta would be a half, so theta's got to be pi sixths there. Similarly for the arc sine of 0 on that. Here you've got a natural log, and that's what you want to let be u, and that's because the derivative of the natural log is 1 over x. And you notice I have a 1 over x dx. There it is. So there's my du on this. And u is the natural log, so I have 1 over the natural log. And so now we're running the integral of 1 over u. The integral of 1 over u is the natural log of u. And this is from x being e to x being e squared. But remember, we can't stay in terms of u. I got to plug u back in. So I have the natural log of the absolute value of the natural log of x from x being 0 e to x being e squared. So let's plug in the e squared, natural log of the ln of e squared minus the natural log of the ln of e. Well, the ln of e squared is just 2. They're inverses, they undo each other. I don't really need the absolute value anymore because I have the natural log of e, which e, of course, is positive. Minus the natural log, and here I've got an ln of e, which is just a 1. Again, I don't need. And the natural log of, oh, I'm sorry, that's the natural log of e squared. Good grief, right here. Natural log of e to the 2 is 2. So I get the ln of 2 minus the natural log of 1, which is 0. So I get the natural log. Oops, natural log of, come on, there we go. Natural log of 2 for our solution on that. And that should get you going. Thanks so much for watching. See you next time.